2024, we have a company making windscreen wipers with a huge amount of writing. But really, when you look at the diagram, we have an arc, and we're asked to show that OB, this side here, is equal to 120. Well, because it's an arc, OB is equal to ON. OB is equal to ON. We have two values here. We have from here to here, which is ONM. NM is equal to 100. OM is the 20 down the bottom here. OM is equal to 20. OM plus NM is equal to ON, which is equal to OB. Therefore, OB is equal to 120. I think that's what they're looking for here. Can't see another way to do it. Part 2, we're asked to show that the angle BOT, this one in here, is equal to 41.4. So if we draw that triangle and put in the angle A, what do we have? We have the hypotenuse being 120, and this is half of 180, so 90 on the bottom. So we can say that the cos of A is equal to A over H, which we can simplify to 3/4. So the inverse cos of 3 over 4, hopefully, is 41.4, and it is correct to 1 decimal place. So that's A. Then we're asked to work out the area of what looks like ABBA. A, B, B prime, A prime, A, B, B prime, A prime. So actually just to here, not this little bit here. So it's the big arc, take away the small arc. So we need to know this angle in here. Well, this angle in here, B, is equal to 90 minus A. So B is 90 minus 41.4, which is equal to 48.6. And we have two of them in here, so we have times 2. That's 97.2 degrees. So the area of the big one, we'll get this is shaded in here, so we're just looking for the shaded area. So it's the area of the big one minus the area of the small one in here minus this one. So the area of the big sector, so pi r squared is the area of the sector, or area of the circle, multiplied by theta over 360. So for the big one, we're going to get pi by the radius, which, make it a bit clearer again, is OB, which is 120. So pi by 120 squared by the angle over 360, 97.2 over 360. That's giving me 122.14.51. So that's the big one. The small one, well, we could use similar triangles. Maybe use this small one here where we have 20 on the side. We're looking for this guy here, we call him X. So the small triangle, I have a right angle, I have an X, and I have a 20. And the big triangle, I have a right angle, I have 120, I have 90 down the bottom. Which angles? This angle is the same on both, so therefore this one must be. So we can say we're looking for X, so we start with X over, sorry, this is 120. So X over 120, 120 in the wrong spot. So X over 120 is equal to, we started in a small triangle, 20, this one, so we need this side here. So the square root of 120 squared minus 90 squared is 30 root 7 on a calculator. So I leave it as 30 root 7. So 30 root 7. So x, the radius of the small one, is equal to 20 by 120 divided by 30 root 7. That will be 80 over root 7. It's very untidy. So the area of the smaller one is pi by 80, what do we say, 80 over root 7, pi r squared, that's the angle's the same, by 97.2 over 360 equals, that equals 775.52452. And if we want the area of the shaded bit, it's 12214.51 minus 775.52. That's given 11438.99. So 11439 cm squared for the area of the sector. Moving to point O, so moving this point changes things. So by setting OE as x and using the cosine rule, find the value of OE. Okay, well, let's have a look here at their diagram. OE and OE prime are the same, they're x and x. It tells us the angle E prime OE, so in here is 105, so that does set up the cosine rule. We do have the 180. So we just have one unknown here, so 180 squared is equal to x squared plus x squared minus 2 by x by the cos of the angle. So 324 is 18 squared, so 32400 equals 2x squared minus 2x squared cos 105. If we divide by 2x squared, no, if we divide by x squared, get x on its own, x squared would leave 2 minus 2 cos 105 equal to 32400. So if I divide, I'll just use the calculator at the end. If I divide by 2 minus 2 cos 105, that will be equal to x squared, so get the square root of it, and we should get x. X is equal to 113.44, 113.44, one decimal place, 113.4 centimeters. And a probability test question thrown in at the end here. Maddie is driving home. The lights can be red, green, or orange. For example, red, red, orange, green, red. How many different patterns could the traffic lights make? 1, 2, 3, 4, 5. In the first one, we have 3 options for everything. So that's 3 to the power of 5, which is 3 squared by 3 squared by 3, 81 by 3, 243. How many different patterns could they make if the first one is red? So we have one option at the beginning. Then we have 1, 2, 3, 4. And the fifth is not red. 2 options, which leaves 3 everywhere else. 27 by 2 is 54. And how many different patterns could they make if no 2 lights are the same? Well, let's start off with red again. So then I've got another 4 lights to pass. So no matter what red is, I have 2 options here. So we're going to have 2 colors, 2 colors, 2 colors, and 2 colors. So that's 2 to the power of 4, which is 16. So if it starts with red, and we'd have to multiply that by 3 if it started with the other 2 colors. So 48 for the last part. Hopefully you got here in a long test.